All right, welcome to my home studio recording office workshop of some sort, mess of other sorts. Yeah, we got all sorts of stuff. Over there's the laundry. Look, this is the behind the scenes right here. You're getting the whole thing. So there you go. Isn't that exciting? All right. Today we're going to talk about ions. If you don't know what those are, that's quite all right. Hopefully you are able to print off the notes and you can just follow along, fill some stuff in as we go. Otherwise, watch the video, take down what you can, rewatch, do whatever you want, really. So let's get going on ions. So what is an ion is a good place to start. An ion is just an atom that now has a positive or negative charge. So remember, an atom originally is neutral. So let's write that here. Originally neutral. So an ion is that neutral atom that now all of a sudden has a positive or negative charge because it gained or lost a specific number of electrons. We'll talk about why in a moment, but for right now, just know that it's gained or lost. So if you gain electrons, I'm going to put a, whoops, I was going to put a, yeah, let's try that again. So if you gain electrons, and we'll put the S in brackets here because it might be one or more. Remember, those electrons are negative, so if you gain electrons, you're taking in more negatives, so you are going to become a negative ion. The opposite is true as well. If it loses electron or electrons, it becomes a positive ion. Because again, if you give away negative electrons, all of a sudden you become positive. All right, so why do they do this? Well, atoms want to have their outermost orbit filled with electrons. That makes them stable. So remember we had this 2-8-8 rule, and we said 2 electrons could go in the first orbit, 8 in the second, 8 in the third. If the first one is full, it would have all 2. If the second one's full, it would have 8. Third one would have 8. So if it's not already filled in one of these orbits, it wants to be filled. That makes it stable. And in order to do that, electron or electrons will be gained or lost. This is really important. Protons are never gained or lost. Remember, we said protons are what makes an atom a specific element. So we don't want to gain or lose any protons. And just a little vocabulary here for you. Electrons in the outermost orbit are called valence electrons. The electrons that are in the inner orbits are called core or inner electrons. What we want to focus on is these valence electrons. So draw a Bohr-Rutherford diagram of a lithium atom. So we're still just drawing an atom here. So Bohr-Rutherford, remember 2 words, so 2 things go in the middle, protons and neutrons. You find lithium, it's atomic number 3, and has a mass number of 7. So it has 3 protons and it has 4 neutrons. So there is our nucleus. For electrons, it should have 3. And go back and watch the video before this if you can't remember how to get these numbers. So following the 2-8-8 rule, I have 2 in the first orbit, 1 in the second. All right, the question is, what will it do to become a stable ion? So it wants to have its outermost orbit filled. So in the second orbit, it can have up to 8. So what would it have to do? It would have to gain 7 to be filled. What's the other option, though, that it could do? It could lose this one, and all of a sudden it would just have 2 in the first orbit, and that first orbit would be filled. So what do you think it's going to do? Lose 1 or gain 7? Lose 1. You always pick the smaller number. So what will it do to become a stable ion? It will lose 1 electron. All right, let's scroll down here. What is the ion's charge? So originally, as an atom, it's neutral. When it loses 1 electron, we're going to put 1 And then because it's losing a negative electron, we said that would make it positive, so we say this has a 1 positive ion charge. Let's try the same thing for nitrogen now. So nitrogen is atomic number 7. Its mass number is 14, so it has 7 protons, 7 neutrons. Here is my nucleus, and following that 288 rule, we're going to have 2 electrons in the first. Sorry for my terrible circles here. You wouldn't believe how hard it is to draw a circle on a little tablet here. So we have 5 here. Remember, we do this in clockwise fashion. So 1, 2, 3, 4, and then the 5th one here. All right, what will this one do to become a stable ion? Well, it's got 5 in the second orbit. We know the rule is to 8, so it can have up to 8. So what could it do? It could gain 3 more, or it could lose all 5 and drop down to the first orbit. Again, we choose the smaller of the two numbers, so gaining 3 is easier than losing 5. So what will it do to become a stable ion? It will gain 3 electrons. And remember, these 5 electrons in the outermost orbit are called valence electrons. So it's going to gain 3 more valence electrons. What is the ion's charge? Well, we write the number 3, and if it's gaining negative electrons, that means the charge is going to be 3 negative. So a nitrogen ion, also known as a nitride ion, will have a charge of 3 negative. All right, this one's a little bit different for 2 reasons. We're drawing a Bohr diagram instead of a Bohr-Rutherford, and we're drawing an ion instead of an atom. So for sulfur, sulfur is atomic number 16, so I need to deal with 16 electrons. I'm not sure why I picked such a big one. So here's S. Remember, Bohr diagram, we put the element symbol in the middle, and we need 16 electrons. So following the 288 rule, we'd have 2 in the first orbit. We will have 8 in the second, 1, 2, 3, 4, 5, 6, 7, 8, and that gives us 10. What did we say? We need 16. So we need 6 more. 1, 2, 3, 4, 5, and 6. All right. This is just an atom right now. We're asked to draw an ion though, so we have to decide what's going to happen. Well, the third orbit can have up to 8. It has 6 valence electrons right now. What's easier to do, gain 2 or lose all 6? If you said gain 2, you're right. So here I'm going to draw in 1, 2. All right. What did it do to become a stable ion? It gained 2 electrons. What is the ion's charge? It is 2, and if you're gaining negatives, it will be 2 negative. Now we've got one other thing with our diagram that we need to change. If I saw you draw this, I would think you just drew it wrong, because this is telling me this is a sulfur atom, and you drew 2, 8, 8, 18 electrons. That's not a sulfur atom, that's a sulfur ion. So what we want to do is we actually want to write that 2 negative charge in the nucleus with the element symbol. So we write it at the top right. So right here we write 2 negative. And you don't need to write it in a different color. I just used a different color so that it showed up here. So when you're drawing a Bohr diagram of an ion, you need to include the ion charge here. All right, let's take a look at some that are already drawn for us and see if we can determine what these are. I'll do 1 or 2 of them, and then I'll get you guys to try them. So what element is this? Well, we know the number of protons right here is 17. That's the atomic number. So we look on our periodic table and we see atomic number 17 is chlorine. So this is chlorine. All right, how many orbits does it have? We've got 1, 2, 3. So we have 3 orbits. Number of valence electrons. So valence electrons are those electrons in the outermost orbit. So we're only going to count those. We've got 2 here, 2 here, 2 at the top, and 1 at the left. So that gives us 7. It has more than 7 electrons, but it only has 7 valence electrons. Is this a picture of an atom or an ion? Well, we have 2 ways of looking at this. We have 17 protons, And if you count up all the electrons, we've got 17 electrons as well. So if we have the same number of protons as electrons, that tells me it's an atom. So this is an atom. It's neutral, same number of positive protons as negative electrons. The other way we could look at this, which sometimes works, sometimes doesn't, is look at the outermost orbit. This is not filled, so we know it is definitely not an ion. It is definitely an atom. If it were to become an ion, though, what would it do? Well, it would only need to fill in one more over here. So this ion charge would be a 1. And would it be positive or negative? If you gain electrons, which are negative, it gives you a 1 negative charge. Let's take a look at this one. What element is this? Well, we again will look at 4p, 4 protons. So that means atomic number 4, which is beryllium, B-E-R-Y-L-L-I-U-M. That's one that you guys spell incorrect quite a bit. Number of orbits, well, the way it's drawn, we've only got 1. How many valence electrons? We've got 2 electrons in total, and they're both in the outermost orbit, so they're both valence electrons. Is this an atom or an ion? So the thing to look at here is if we have 4 protons and only 2 electrons, that means it would have a charge. They're not equal to each other, so this is an ion. Remember, in an atom, both the number of protons and electrons are going to be equal to each other and equal to the atomic number. What ion charge does this have? Well, if it has 4 protons, as an atom, it should have 4 electrons. But we only have 2 drawn here. So we know that it's lost 2, which gives us an ion charge of 2. And if you lose electrons, you give away negatives, you become positive. So this is 2 positive. All right, you guys pause the video, try this one. All right, if you've tried this element, there's 12 protons, so this is magnesium. That's atomic number 12. The number of orbits is 2. The number of valence electrons in the outermost orbit, 2, 4, 6, 8. Is this an atom or an ion? So you take a look at how many protons there are, 12. How many electrons are there? There's only 10, so we know that the number of protons and electrons are not equal, so this is an ion. This is a charged atom. What ion charge does it have? Originally, it should have 12 electrons to match up with the 12 protons, but since it only has 10, that means it lost 2 electrons. Same as the last one. If you lose electrons, you become positive. So 2 positive. All right, so you guys can go ahead and try to complete the remainder of the Bohr and ions assignment.